Greetings, M squared here. Today we're going to talk about isosceles triangles and their properties and a couple theorems that we're going to learn about them. So what we have first is we need to know what an isosceles triangle is. And an isosceles triangle is a triangle with at least two congruent sides. And that's what we're going with, at least. I didn't put the word at least, but it is at least. So an equilateral triangle is also considered an isosceles triangle. So isosceles triangles have special names for their legs and angles, so we're going to learn about those. So first we'll do the angles. The angle, so if these were my two congruent sides, the angle that connects the two congruent sides is called the vertex angle. And the other angles are called base angles. These sides that are congruent are called legs, and the other side that's not congruent is called the base. So you might have some problems where you have to know what those mean. Make sure you understand what the legs are, that they're the congruent sides. The base is the not congruent side, and vertex angle and base angles. All right, so our first theorem is the isosceles triangle theorem, and it says if two sides of a triangle are congruent, then angles opposite these sides are also congruent. And basically it means that the base angles of an isosceles triangle are congruent. So if you know two sides of a triangle are congruent, then you can assume through this theorem that the base angles are going to be congruent. Now the cool thing is it goes the other way too. If you know that the base angles of a triangle are congruent, you can tell that the sides are congruent. That's called the converse. So let's write the converse for our theorem. And it's going to say if two angles of a triangle are congruent, then the sides opposite those angles are congruent. That's the converse. So you can use either one of those in our proofs or in our examples. We'll do a few examples today. So if you know the sides are congruent, you know the angles opposite them are congruent. If you know the angles are congruent, you know the sides opposite them are congruent. So there's a couple other things we want to know about an isosceles triangle. The segment that is going from the vertex to the midpoint of the base of an isosceles triangle is, wait a minute, I lost my train of thought, sorry. The segment of from the vertex angle to the midpoint of the base of an isosceles triangle is perpendicular to the base and bisects the vertex angle. So let's talk about that. If it's perpendicular to the base, we can know that those are 90-degree angles. And if it bisects this angle, we know that this angle is congruent to that angle. I offset them so it doesn't look like one big angle. So these are the two angles that are congruent because this line that goes from the vertex to the midpoint of the opposite side bisects that angle. And also, if that's the midpoint, I know that these two are congruent. It was isosceles, so I know those two are congruent. I know it's isosceles, so the base angles are congruent. So you can kind of see how we know a lot of stuff if it's an isosceles triangle. And all of that stuff comes into play when you see pictures. You want to remember all that. So angle ABD is going to be equal to angle CBD. So that's what that is. The segment from the vertex to the midpoint of the base of an isosceles triangle divides the triangle into two congruent triangles. And we're going to talk a lot more about congruent triangles coming up. But basically, this triangle is congruent to that one. If I folded it in half on that line BD, it would be exactly the same. So that means triangle ABD is going to be congruent to triangle CBD. So triangle CBD. Okay, so we're going to talk about two things. You should have probably learned this before, but just keep this in mind. A segment in a triangle that goes from a vertex or angle to the midpoint of the opposite side is called a median. So we just know that that's what this is called. In an isosceles triangle, that's called a median. Okay, but there's one more. It's an altitude. A perpendicular segment in a triangle that goes from a vertex to the opposite side is called an altitude. Well, that's what this was too. So in an isosceles triangle, this line that goes from the vertex to the midpoint of the opposite side is both an altitude and a median. You'll see pictures. A median doesn't necessarily have to be perpendicular, just divides a side in half. And a altitude isn't always inside a triangle. You'll see in this obtuse triangle, it's actually outside because it has to go from a vertex to the opposite side, but the side stopped there and you can't get it perpendicular there, so you kind of have to extend the side. So just keep that in mind too. All right, so now we're going to do some examples with isosceles triangles. So I'm just going to do a couple of these. These are from your homework. Find the measure of a vertex angle of an isosceles triangle if the base angle is 42. I always like to draw a picture. So I draw a picture. I know this is what I'm trying to find. I'm going to call it x. I know my base angle is 42, but in an isosceles triangle, I know that the base angles are exactly the same. So what I need to know then is that all the angles of a triangle add up to 180. Those two add up to 84. And if I subtract 84 from 180, that's how I can find my x. So I get 96, I believe. All right, I'm just going to randomly do one more, and then I'm going to leave it up to you. So if you look, you can see the little tick marks. That means those two sides are congruent, which then tells us these two angles are congruent, and they actually tell us the binomials that represent those two angles. So if I know those angles are congruent, then I'm going to set them equal to each other, like this. And then I'm going to solve for t. So I'm going to subtract 3t from both sides and get 2t. I'm going to add 13 to both sides and get 16, so that means t equals 8. But I'm not done because look at the directions. It said find the measure of angle x. So I have to take my 8 and I have to plug it back in for my t. So 5 times t is 40. 40 minus 13 is 27. So my angle x, the measure of my angle x, I should say, is 27. So in all of these, you're going to be using the isosceles triangle theorem, where it says base angles of an isosceles triangle are congruent. You might also use stuff we learned before, parallel, the angles that are congruent when lines are parallel, or vertical angles, or linear pairs. So there's lots of different things. That's the last example I'm going to do because I want you to do that for homework. Good luck. M squared, signing out.